there are 6 basic law of indices. We're going to see the 6 rules. Rule number 1. Any variable or number raised to the power of 0 is 1. This is the first rule. In this first rule, for example, x to the power of 0 is 1. 2 to the power of 0 is 1. Minus 5 in bracket to the power of 0 is 1. However, minus 5 to the power of 0 is not 1 because this 0 is at the top of 5. Hence, it is 1, but there is a minus here. This is a variation. If I have g m1 m subscript 2 over d to the power of 2, as long as all these are having zeros at their powers enclosed in a bracket, this is equal to 1. According to this rule, it doesn't matter how complex the equation looks like. As long as this equation is enclosed in a bracket and is to the power of 0, this rule number 1 states that it must be equal to 1. Always remember this in mathematics. Next, rule number 2. In the second rule, we have a to the power of minus m is 1 all over a to the power of m. For example, if I have 2 to the power of minus 3, according to this rule, it's going to be 1 over 2 to the power of 3, which is 1 over 8, because we have 2 times 2 times 2. That is 2 times 2 times 2 will give us 8. Also, if I have a, b to the power of minus 4, a and b are multiplying. According to this rule, I'm going to have a, this minus 4 is affecting only b and not the a. So a is free at the numerator. And according to this law, b will come down with the 4 at the power. According to the second rule. According to this second rule, if I have 5a, b in bracket, all to the power of minus d, divide by 3. This rule states that this 5 will be at the numerator. And here we got 3. However, because of this law, a and b will come down with the d, taking off the negative. This is the application of the second rule in the law of indices. Next, let's consider rule number 3. The third rule states that a to the power of m multiplying a to the power of n is a, I will add the power m plus n. This is like taking this multiplication sign and turning it 45 degrees to become a plus. For example, if I have 2 to the power of 3 multiply by 2 to the power of 5, these two are the same according to this law. Hence, I'm going to have 2, then this will become 3 plus 5. I will end up having 2 to the power of 8. Also, if we have 3m square r multiplying 4 m cube r to the power of 6. If I want to solve this expression, I will apply the law of indices. I will bring the numbers together. 3 will multiply 4. Hence, I will have 3 times 4. Next, I will bring the m together. That is, m squared is multiplying m to the power of 3. Next, I will bring the r's together. Hence, r is multiplying r to the power of 6. With this will become 12. This m and this m are the same according to this law. Hence, I will have m 2 plus 3. Next, r here is 1. I will have 1 plus 6 according to the law of indices, because r and r are the same. Hence, I will have 12m to the power of 5, r to the power of 7. And this will become our simplified result according to rule number 3. Also, if I have p to the power of 2 multiply p to the power of n is equal p to the power of 6. And I want to find n. What is n in this equation? I will apply the law of indices because these two are the same. And I'm going to have p2 plus n according to the third rule. And here is p to the power of 6. Next, because this p and this p are the same, raising variables or numbers up in mathematics, this p can cancel this p, and we're going to have 2 plus n is 6. We want to make n the subject. N is on this side. On the other side, we have 6. If 2 moves across this equal sign, it will become minus 2 because it is plus 2 on this side. And our n is 4. You see, we could solve this because we applied rule number 3. Next, rule number 4. If we have a to the power of m and a to the power of n, and they are separated by division, that is, this is dividing this, the rule states that since these are the same, I will subtract the powers. For example, if I have 3 to the power of 7, divide 3 to the power of 2. According to this law, I will have 3 because they are the same. If they are not the same, I can't do this. I'm going to have 7 minus 2. And we're going to have 3 to the power of 5. This is like having 3 times 3 times 3, doing this 7 times, and dividing it with 3 times 3. And here, this will cancel this, and this will cancel this. And you end up having 1, 2, 3, 4, 5. And we are going to have 3 to the power of 5, just like we obtained here. We just applied the fourth rule. Also, if we have n to the power of 4, dividing n to the power of 1 over 2. As long as this is n and this is n, we're going to apply the fourth rule, which states that n is common. We're going to have 4 minus 1 over 2. And from basic mathematics and from subtraction of fractions. If I have 4 over 1 minus 1 over 2, this will multiply this, I will have 8. This will multiply this, and I will have 1. This is minus. Next, this times this will give you 2. And you end up having 7 over 2. Hence, I will have n is to the power of 7 over 2. And this is our answer for this question. Remember, for this fraction, this will be first, this will be second, and this movement will be the last. That's how we obtained 7 over 2. Still on rule number 4. If I have 2 to the power of 30 dividing 8 to the power of 9, and on the other side it is 2 to the power of x. Let's find x. To find x here, we are going to apply on this side the fourth rule. To apply the fourth rule, you need to change this 8. 8 is the same thing as 2 times 2 times 2. That is 2 to the power of 3 is the same thing as 8. Hence, instead of writing this 8, I will write 2 to the power of 3. Hence, I'm going to have 2 to the power of 30 divide 2 to the power of 3. However, there is a 9 outside here. And here we have 2 to the power of x. Next, I will have 2 to the power of 30 divide 2. 3 times 9 is 27. And on the other side, I got 2 to the power of x. This is now the fourth rule. So these 2 and these 2 are the same. I will have 2 to the power of 30 minus 27. I'm done with this side. On the other side, I got 2 to the power of x. This is 2. 30 minus 27 will give you 3. And I got 2 to the power of x. In mathematics, as long as there is an equal sign here, and these 2 are the same, I can have 2, 2, or 5, 5, or 7, 7, or even minus 5, minus 5. But if this is minus 2 and this is 2, then this problem becomes undefined. For example, I have minus 2 to the power of 3 and I have 2 to the power of x. This becomes undefined because these 2 are not the same. I will stop every mathematical solution. However, because these 2 and these 2 are the same, they can cancel out. And here I got 3 is x. That is, x is equal 3. And this is our answer for this problem. Next, let's consider the fifth rule. The rule states that if we have a to the power of m and this is in bracket n, we're going to have a to the power of m n. That is, this at the power will multiply. The fifth rule can be splitted into 2 to accommodate other variations. That is, here, if I have a, b to the power of m, I can have a to the power of m and b to the power of m. This is a variation of the fifth rule. Also, I can have another variation of this fifth rule, which states that a over b all to the power of m. And I'm going to have a to the power of m divide b to the power of m. The fifth rule is simply a variation of these two other rules. This is the reason you can hear 8 rules of Law of Indices. Basically, we have 6 rules, But if you add these two other rules to this 5 plus the 6th rule, you end up having 8 instead of 6. With this rule, for example, if I have 2a to the power of 3 all to the power of b, I'm going to have 2 to the power of b and a to the power of 3b according to this rule. Also, if I have 2 over 3 in brackets all to the power of 4, I'm going to end up having 2 to the power of 4 divide 3 to the power of 4 according to this variation. Also, if I have 8e to the power of 6 divide d to the power of 12, everything is enclosed in this power, which is 1 over 3. I'm going to apply this variation. Remember, this and this and this are the same. It's just little variation, but the rule still applies. That is, I'm going to have 8 to the power of 1 over 3, and this e to the power of 6 will multiply 1 over 3, and this d at the denominator will also multiply 1 over 3 according to the 5th rule. This can become, this is the same thing as saying the cube root of 8 multiply, this is e to the power of 6 over 3, and this is d, 12 divide by 3. The cube root of 8 is 2, this is 1, and this is 2. So we are going to have e to the power of 2. Divide, this is d, this, we take away this, and we're going to have 4. This becomes our answer. You can write this as 2e to the power of 2 and d to the power of minus 4. This and this, both are the same according to the second rule, because I can take d with its power up and it's going to acquire a minus. That's exactly what I did here. You see, in this question, I've applied 2 rules already, if you consider this. Next, let's have rule number 6, which is the 6th rule. The rule states that a to the power of m divided by n is the same thing as saying a to the power of m in bracket 1 over n. In mathematics, if I have the square root of 2, this is the same thing as saying 2 to the power of 1 over 2. The square root of 4 is the same thing as saying 4 to the power of 1 over 2. And this is 2. If I say the cube root of 8 is 8 to the power of 1 over 3, and the same thing as 2. Hence, if I have p to the power of 1 over n, this is simply saying the root, the nth root of p. This n can be any number. For example, p to the power of 1 over 5. This is saying that this is the 5th root of p. With this understanding, we can say that the 6th rule is a to the power of m, then the root of this a to the power of n. This is the 6th rule. From this 6th rule, we can have that a to the power of 1 over 2 is the square root of a. If you add the 6 rules we have here and these 3 variations, we're going to have a total of 9 basic law of indices. However, we have only 6. The most important thing here is knowing when and how to apply each of these rules in basic mathematics. If you find this video helpful, feel free to click the like button. Also, subscribe for more videos like this. I will see you in the next video lesson.